Order of the days. We're just going to do this a whole bunch of times. Now, one thing that I didn't tell you last time is that we're going to have a cat join us. My cat is like right next to me and she thinks that I'm talking to her and not you. So she demands to be played with while I do this. So if you hear a cat in the background, that's what that is. Um, anyway, we're just going to do this a bunch. One thing I didn't tell you last time is if how you get some of these numbers. A big trick is if you want a 1, you're going to multiply by something. If you want to get a 0, then you'll add or subtract. Actually, if you want a 1, you can actually multiply, or you can do that row switchy thing. That also will help to get the things that you need. Okay. So this is the first example that I showed in class last time. I think I just did the beginning part of it. I don't think I actually solved it. But I'm going to start with this one because I just kind of wrote it up on the board, but I didn't actually do anything with it. Well, I didn't really explain what I was doing. So I'm just converting this into an augmented matrix. There we go. And what I want to do is I want to follow the process. I need to get a 1 right there. And I see one, there's one right below it. So I'm going to use the row switchy thing. I'm going to take row 1 and I'm going to swap it with row 2. Because when I do that, then this row goes up here and I get the 1 that I was looking for. So, that's great. I don't really care about what else is happening. All I care right now in this step is what's going on with that 1. And I got the 1 that I needed. Now, sure, there is a 1 down here, but I'm not attached to that 1 yet because I'm not on that step yet. So I'm probably going to lose that 1. So I don't want to get attached to it and say, oh, I got to keep that 1 there. You got to just let that fall apart. Right. Mel agrees. Okay. So next, we got to get this 2 over there to be a 0. We want to fix that thing next. So to get that thing to be a 0, we have to add or subtract. And we use the one that we just got. I can't decide if she wants me to keep playing with her or if she's ready to sleep. Hopefully it's the sleep option. All right, we're going to do 2 times row 1. Sorry, negative 2 times row 1. And we're going to add that to row 2. Because if we do negative 2 times 1, that'll be negative 2. And if we add that to row 2, then we'll get 0. Yes, you could do the same thing by subtracting, but I always add the rows. I take care of the negative right away because if you have to do subtract negatives, then it confuses me. Anyway, we're going to just put that in row 2. All right, so I'm going to copy the row where nothing's happening. Nothing's going to happen in row 1. But in row 2, we're going to do negative 2 times 1. It's negative 2 plus 2. That's 0. And that's what I wanted. Then I've got to do negative 2 times that 3 right there. Negative 2 times 3 is negative 6, plus this 1 right there is going to be negative 5. Then we got to do negative 2 times that 6 up there. That's negative 12, plus this 8 right there. So that's going to be negative 20. I forgot that bar from my augmented matrix. Okay. See, the 1 disappeared, but I'm not upset about it because all I really wanted in this step was that 0 right there, and that's what I got. Now let's refix this. Now we got to turn that back, and that's just going to be fine. That's what we need to do. So I'm going to do negative 1/5 times row 2. And I'm doing that to turn it into a 1. Whenever you multiply, you either do the row switch, which I did up here, or you multiply. In this case, we're going to multiply by 1/5, negative 1/5, because that'll turn it into and 1. We're going to put that in row 2. So copy the row that doesn't change. And in the row that does change, we do have to multiply all the numbers. So 0 times negative 1/5 is 0 times this negative 1/5 is still 0. Then negative 1/5 times that negative 5, that turns into a 1, which is what we wanted. And then we got to do negative 1/5 times 20, and that is going to be 4. All right, now there's a final step. We want to get it into reduced row echelon form, because this is row echelon form right there. We did it. Row echelon form achieved. If you want to get into reduced row echelon form, we have to get this 3 into a 0. So we'll do the same thing. So we'll do negative 3. My cat has left. She's just like walked away, and it's great. Negative 3 times row 2. We're still going to use row 2 where that 1 is, because that's the easy way to do it, plus row 1. We're going to put that in row 1. Okay. So, copy the row that doesn't change, 0, 1, 4. And let's do the row that does change. 0 times negative 3 is 0 plus 1, so that's still a 1, good. Negative 3 times 1 is negative 3, plus this 3 is 0. Negative 3 times 4 is negative 12, plus that 6, that is negative 6. And then we're pretty much done. We can convert it back. X equals negative 6 and y equals 4. And that is a solved matrix. It's a 2 by 2, all done. I'm going to do another one now. Woo! Okay, so in this one, I've taken care of the boring step of converting this thing into a augmented matrix. And I also wanted to quick remind you of the process to make sure that you've got the right answer, so you can put this thing into your graphing calculator. So quick reminder how to do that. If you go second matrix and then move your way over to edit, here you can edit the matrices. And I've already put this one in, so I've got a 2 by 3 matrix, and I put in all the values. Then to solve it, all you have to do is, once again, go to matrix after you've quit it out. Otherwise, you'll try to solve a matrix inside of a matrix, and then it all falls apart. You want RREF. There we go. And RREF, reduced row echelon form. That's what happens when we've solved the whole thing. And boom. And you'll get this. But something seems to be going awry in this one. So this is an interesting case where it all sort of falls to pieces. And I'll show you what happens inside of this. But this will be kind of our end game. So if we get to that, we have done it right. So as we solve this one, the first thing we want to do is we want to do negative 1 times row 1. I'm going to put that in row 1 to turn that first thing right there into a 1. So copy the matrix to negative 4, negative 6. I just need to change the sign of everybody in that first row. And then I want to do negative 2 times row 1, and we're going to add that to row 2, and we're going to put that in row 2, because all I want to do is make that thing into a 0. I don't really care about, well, for the most part, I don't really care what's going to happen with the other ones. I just want to turn that 2 into a 0. Copy the top row. And negative 2 times 1 is negative 2, plus 2 is 0. Negative 2 times negative 2 is 4, plus negative 4 is also 0. Negative 2 times negative 3 is 6, plus negative 6 is 0. that whole row dropped out. There's no more of that row, which means we haven't been able to solve it. And we can't do anything to turn that 0 into a 1. If I multiply it by stuff, because that's how I try to turn that into a 1, anything times 0 is just going to stay 0. Convert this back for a second. You end up with x minus 2y equals -3 and 0 equals 0. If you've got a two-variable system, you need two equations in order to be able to solve it. We weren't given two different equations up here. If you multiply this thing by -2, you'll find that these two are the same equation. Since they're the same equation, we weren't given two different equations. This thing has infinite solutions. We weren't given enough information to solve it for one specific point, so we end up with an infinite number of solutions. Now, as a side note, this could have turned out worse. This one actually turned out okay. It could have turned out worse. If we had some other equation, say we ended up with 3x plus 4y equals 7. I'm just making this up. And then we got to that endpoint and we got 0 equals 14. 0 does not equal 14. So this one, it's worse than getting the same equation. We got an equation and something that's unbalanced. Since that thing is unbalanced, we have no solutions. So if you get to that point where you're not able to make ones because your whole row became zeros, or like this whole chunk right here became 0 somewhere, then double check, make sure you haven't done anything wrong. And otherwise, you just have no solutions for that one. So, and that's it. That's all we have to do on that one. We're not going to go any farther because we can't. That's just sort of done. Yeah, cool. Next example.